What's money? We use money all the time, but have you ever thought about what it really is and how it works? Imagine that you go to McDonald's. You can pull a piece of paper out of your pocket and give it to a person there, and they will give you a hamburger. You can get something you want by just giving them that piece of paper. Now, you can't do that with just any piece of paper. You can't just reach in the trash can and grab a piece of scratch paper, take it into McDonald's, and exchange it for a hamburger. There's something special about the dollar bill that you use. It's a special kind of paper. You could also use plastic. If you have a credit card, you don't even have to give it to them. You can just put it into their little reader, and they will give you a hamburger. There's nothing about the plastic itself that makes it worth them trading a hamburger for it. You can't go in there with an empty milk jug and exchange it for a hamburger. It just doesn't work that way. What makes the money and the credit card able to cause change in the economy and get you what you want from McDonald's is the fact that they stand for something else. They stand for the ability to cause change in the economy. So you might be asking yourself, what does this have to do with science? Well, we're going to start out talking about wealth because it's a great metaphor or analogy for an important concept in science that lots of people don't understand, called energy. Wealth is a lot like energy in many of its aspects, and so we're going to use it as a way of getting a foothold into the concept of energy. Just like wealth is the ability to cause change in the economy of all different kinds, energy is an ability to cause change in the physical world of all different kinds. That's not the only thing that these two quantities have in common, and so we're going to spend a little time talking about wealth because it's a little easier to understand than energy, and it might make it easier for you to make the transition when we begin to talk about energy. Here's some wealth data for a particular imaginary guy that we're going to use to think about wealth. This is his wealth picture. He has a checking account with $5,000 in it. He has a savings account that has $30,000 in it. He owns some property. In specific, it's a car that's worth $7,000, and in his pocket he has $500 of cash. That's how he stores his wealth. When I ask students to draw a graphical representation that models this wealth picture, this is what I usually get, a pie chart. And it's a great choice. The total size of the pie shows how much wealth he has, and the individual slices show what part of his wealth is stored in different ways. So his checking account, shown here in yellow, is one of his ways of storing his wealth. Property, shown here in red, is another way he's storing wealth. Savings account is another way he's storing wealth. And cash is another way he's storing wealth. So even though all of his wealth might be measured in dollars, a very small part of his actual wealth is real dollars, like dollar bills. That's only the little skinny purple slice. So dollars is a way of measuring wealth, but you don't have to have dollar bills to have wealth. Wealth is the ability to cause change in the economy. And there's all kinds of changes you can cause. You could buy the things that you need or want. You can pay somebody to do a job you don't want to do or don't have time to do. You can even loan your wealth to somebody and rent it to them. That's what an investment is. They take your wealth, they use it to create some wealth of their own, additional wealth, and they give you a share of that back. Wealth storage isn't static. Let's say this person is making a change. He thinks he wants to buy a new car. So to prepare for that, he transfers $12,000 from his savings account to his checking account. Here's what that change looks like. Two things stay the same. The amount of property that he has and the amount of cash that he has stay the same. But his savings account shrinks and his checking account grows. That's an internal change. The overall size of the pie doesn't change, but the size of the individual slices do. Now he's ready to make another change. He's finally found the car that he wants. It's worth $12,000, and that was his budget. His Venmo is attached to his checking account, and so he uses Venmo to transfer $12,000 to the seller of the car, and the seller of the car transfers wealth back to him by signing the title to the car. Here's the change. Savings and cash, no change at all. Checking shrinks by $12,000. Property grows by $12,000. Total pie, same size because he still has the same amount of wealth. It's just stored in different ways. His sister needs a car, and so he sells it to her for $5,000 cash. Here's how the change takes place. Savings is not going to change, but cash is. His cash grows by $5,000. His property drops by $7,000 because the car was worth $7,000. He gave his sister a break. Checking stays the same, savings stays the same. The total pie has now shrunk by $2,000. It's payday. He has a job. His salary transfers into his checking account directly through an ACH, that's a kind of wire transfer, $2,000. Here's what that looks like. Savings is going to stay the same, cash is going to stay the same, property is going to stay the same, but his checking account grows. This represents a total increase in his wealth, and so the pie grows back to its original size before he sold his car to his sister. Okay, so here's how wealth is like energy. There are four main ways. One is, like energy, wealth is the ability to cause change. Wealth can cause change in the economy by getting you things that you want or services that you want, but energy causes change in the physical world. Mostly how we see this change evidenced is something slows down or speeds up, or starts moving or stops moving. So changes in motion is one way that we know energy has been exchanged. And the other way is if something gets hotter or colder, we know that energy has been exchanged. Also, like wealth, energy is measurable. You may have heard terms like BTUs or calories or watts. These are all ways of measuring energy. They're units of energy storage, like dollars or euros or yen would be units of wealth storage. A BTU or a calorie isn't a thing, just like a dollar or a yen or a euro isn't really a thing. You don't have to have a dollar bill to have a dollar. But they are ways of measuring. Like wealth, energy can be stored in different ways. And in this video, we're going to explore 5 different ways that energy can be stored. And the fourth way that the two are the same is that they can be transferred in different ways. We saw that he could use Venmo, he could use internal transfers between his accounts, he could use a title transfer, he could use an ACH, and just exchanging cash were all different ways that energy could be moved around, both inside of his wealth system and between wealth systems. Energy also can be transferred in different ways. There aren't as many, there's only 3, and we'll talk about those in a later video. So let's take a look at these energy storage modes. So just like checking, savings, cash, and property were ways that wealth could be stored, we're going to look at 5 ways that energy can be stored in the physical world. So these energy storage modes are just ways of keeping the ability to cause change in an object or a group of objects that we call a system. One way of storing energy is through what we call gravitational energy. In this storage mode, an object has energy because it's held away from the surface of the Earth, which it's attracted to by gravity. So you can see that there's change being caused in this tent peg as the rock falls on it. It drives it further into the ground. One of the things that we know about gravitational energy storage is if you drop the same rock from a higher height, it will cause a bigger change. So when you move an object farther away from the surface of the Earth, it stores more energy in the gravitational energy storage mode. Another energy storage mode is what we call kinetic energy storage. Here we see the green car bumping into the back of the blue car, and it causes a change in the state of motion of the blue car. Because we see a change in the state of motion, we know that energy is being exchanged here. If the green car is moving faster, it will cause a bigger change in the state of motion of the blue car. So more speed means more kinetic energy. So objects that are moving faster store more kinetic energy than objects that are moving slower if they both have the same size. But size makes a difference as well. Here we have 2 different vehicles moving at the same speed, the small green car and the big huge bus. The bus is moving at the same speed as the car, but it causes a larger change in the state of motion of the blue car because it's heavier. Another energy storage mode is what we call thermal energy storage mode. When things get hotter, they store more energy in the fact that they're hotter. Chemists have shown us that this is because of the random motion of little tiny particles vibrating or jiggling around at a dimension that's way too small for us to see. So this iron frying pan, the little particles of iron are jiggling around rapidly enough that they can cause change in this stick of butter that's been thrown into the frying pan. A hotter frying pan stores more energy because all the particles are jiggling faster, and so it can melt the butter even more quickly. So hotter things store more thermal energy than colder things. Another energy storage mode is elastic energy. This is when stretchy things get stretched or squishy things get squished, is the simplest way of saying it. So a spring is a great example of this. When the spring is compressed, it stores the energy that it needs to cause a change in the state of motion of the yellow block. The more you compress the spring, the bigger change it can cause in the state of motion of the block. So more stretch or more squish means more energy is stored in an elastic energy storage mode. Springs aren't the only thing that store elastic energy. A rubber band, a rubber bouncy ball, anything that you can change its shape and it will return back to that same shape after it's released, that has the ability to store energy in the elastic energy storage mode. Here's the last energy storage mode we're going to talk about. It's chemical energy storage. Now the details of how this works, that's a topic for a specific chemistry class. For our purposes, we could suffice it to say that anytime there's a change in the state of motion of an object or in the temperature of an object because of food, fuel, or a battery, we know that chemical energy storage was involved. So we've taken a look at wealth as an analogy for energy. Like wealth, energy can be measured, it can be stored, it can be transferred around, and it is the ability to cause change.